What would you do if you owned a tiny 2005 Japanese K-truck, weighing only 635 kilograms and producing just 49 horsepower? For most people, it would simply be a small utility truck. But for Drew, it became the beginning of an ambitious project. Starting with an old tiny K-truck, he decided to transform it into a fully functional mini camper. Compact on the outside, yet hiding a surprisingly comfortable and cleverly designed living space inside. Starting with an old tiny K-truck, he decided to transform it into a fully functional mini camper. Compact on the outside, yet hiding a surprisingly comfortable and cleverly designed living space inside. Starting with an old tiny K-truck, he decided to transform it into a fully functional mini camper. Compact on the outside, yet hiding a surprisingly comfortable and cleverly designed living space inside. Facing strict weight limits, I abandoned traditional wood construction for a lighter solution. An ultralight wooden frame combined with rigid foam insulation created a structure that was both strong and lightweight. Fiberglass and epoxy then reinforced the entire shell, creating a waterproof composite structure built for adventure. After measuring the truck bed, I milled 2x6 lumber into precise 1.5-inch 2x2 pieces to build an ultra-lightweight frame. The frame was assembled and reinforced with screws and braces for added strength. The rigid foam panels were precisely cut using a track saw and fitted tightly between the wooden frame, creating a smooth and seamless wall surface thanks to their matching thickness. Eliminating traditional plywood significantly reduced weight, but also made the foam more prone to movement during assembly. To keep everything secure, temporary nails were driven through the frame to hold the foam panels firmly in place before reinforcement. To strengthen the structure, the foam surface was first sanded to improve adhesion, then coated with lightweight filler to smooth out imperfections and fill gaps. To reinforce the walls, I covered the entire surface with wide 10-ounce fiberglass cloth to minimize seams, then mixed epoxy to the correct ratio, and used rollers and spreaders to fully saturate the fabric. After around 4 to 5 hours, when the epoxy had partially cured but was still flexible, the excess material was carefully trimmed for clean edges. Once fully cured the next day, the surface was sanded smooth with 120 grit sandpaper, coated with multiple primer layers, and finished with white exterior paint to create a durable and waterproof composite shell. To install the large wall panels quickly and accurately, I used small wooden blocks as temporary guides along the floor edges, allowing the walls to self-align and stay in position during assembly. Once aligned, long screws were driven diagonally through the wooden frame and into the floor to create a strong connection with the base structure. Additional screws were then added to lock the entire structure together into one rigid assembly to create a warm interior accent without adding significant weight. I installed ultralight cedar wall panels less than 1/4 inch thick on the front cabin wall. The panels were joined using tongue and groove connections, then secured with construction adhesive and brad nails for a strong attachment to the frame. Finally, nail holes were filled. The surface was sanded smooth, creating a seamless, warm, and natural-looking wall finish. Finally, the wood surfaces were finished with oil to enhance the natural grain and provide extra protection. To begin the interior build, technical drawings were used to accurately plan the layout and dimensions inside the vehicle. To reduce weight while maintaining strength, Drew built the utility cabinet using an ultralight 2x2 wooden frame instead of traditional full plywood construction. This approach allowed most of the cabinet structure to be completed quickly while keeping weight to a minimum. The visible surfaces were finished with thick maple plywood for a cleaner and more premium appearance. During assembly, components were drilled, glued, brad nailed, and screwed together, then sanded to create a smooth and clean finish. The front panel was completed with a shaker-style door using concealed hinges, giving a clean and seamless appearance. I started by assembling the maple frame with pre-routed grooves, then sliding the plywood core into place to form a tight square structure. The frame edges were sanded to smooth the joints, remove wood splinters, and prepare the surface for finishing. A jig was used to drill precise recesses for concealed hinges. Then the hinge was aligned and screwed in place to ensure smooth, flush, and accurate door movement. To maximize space inside the camper, Drew designed a multifunctional bed and sofa system using a 2x2 wooden frame combined with plywood. I started by cutting and assembling the 2x2 lumber into a grid-like support frame, temporarily fixing the joints to check alignment before permanently screwing them together to ensure the load is transferred directly to the vehicle floor. The frame was then test-fitted inside the van to confirm clearance with the utility cabinet and surrounding space, while maintaining open storage underneath for drawers. The outer shell was built from 1/2 inch plywood in an L-shaped design with cutouts for sliding drawers, then finished with wood filler, sanding, priming, and paint to improve durability and appearance. Finally, the entire bed/sofa module was installed into the vehicle and securely fastened to the floor, completing a clean and fully integrated main living space. Starting with the smallest details, Drew applied maple edge banding to the plywood edges using heat-activated glue, pressed it down with an iron, then trimmed and sanded it to create smooth, seamless edges. Once the box was complete, the drawer was installed into side-mounted slide rails within the sofa structure, ensuring smooth and stable movement. The front panel was carefully aligned, attached with glue and screws, and finished with a minimalist handle. The drawer box was mounted onto side slide rails inside the sofa frame, ensuring smooth and stable movement. The front panel was precisely aligned, then glued and screwed in place, followed by a minimalist handle for easy use. To improve functionality, an electrical outlet was integrated into the side of the drawer for convenient power access. Next, I built a large rear drawer system that functions both as storage space and an extendable outdoor dining table using heavy-duty long slide rails to ensure durability and smooth operation over time. luck came when I found a solid 3/4-inch walnut slab, perfect for the camper kitchen countertop. I used a track saw to make precise cuts and divided the slab into 2 functional sections. One side is a hidden hinge access panel, allowing entry to the battery and wiring system underneath, while still maintaining a clean flat surface when closed. The entire surface was finely sanded and lightly edge-rounded for safety and a refined finish. The other section was precisely cut to fit a RV sink, and the cutout piece was reused as the sink cover, ensuring a continuous and seamless wood grain. The surface was finished with oil and wax to enhance the wood grain, improve durability, and increase water resistance, then securely mounted to the cabinet using silicone adhesive and reinforced screws. At the heart of the system is a compact yet powerful ECO-worthy 12-volt automatic pressure pump, responsible for drawing water from the tank and pushing it to the faucet whenever the valve is opened. I use PEX tubing combined with brass fittings to build a solid water supply line behind the sink. The joints are secured with crimp rings, ensuring a watertight and stable system even when the vehicle is in motion and subject to vibration. The system is simplified by removing the water heater, meaning both hot and cold faucet valves share a single water source from the pump. A flexible intake hose is placed directly into the fresh water tank to supply the entire system. I arranged 2 5-gallon tanks, one for fresh water and one for gray water, neatly placed under the sink. The tank lids are drilled so hoses can pass directly through, making them easy to remove, clean, and refill when needed. The 12-volt pump is connected to the vehicle's electrical system. During testing, simply opening the faucet immediately activates the pump, delivering a smooth and strong flow of clean water into the steel sink with no leaks and stable operation. I use the EcoFlow River 3 portable power station as the main power source for the vehicle. It has a capacity of around 300 watt-hours and includes full AC-C and solar charging ports. To extend usage time, I add an expansion battery underneath. This increases the total capacity to about 900 watt-hours, enough for long trips. For the 12-volt DC system, I install a fuse panel to manage and protect the electrical flow. Power is supplied from the EcoFlow via a car cigarette lighter style cable. It is then connected to the fuse panel using ring terminals. Each DC device, such as lights or the water pump, is powered through its own individual fuse. This makes the system safer and easier to control. For 220 volts AC power, I use a standard power strip. I plug it directly into the EcoFlow AC outlet. This creates a simple and practical setup for devices like laptops and small appliances. The entire electrical system is neatly integrated behind the kitchen cabinet. It is safe, easy to use, and ready for the mobile kitchen. I chose a 21-inch Amazon Echo Show as the entertainment screen for the camper due to its ultra-slim design, allowing it to sit flush against the wall like a digital frame, perfect for Netflix and YouTube. To ensure stability while driving, I reinforced the plastic frame behind the wall and secured it directly with screws, keeping the screen stable and free from vibration. Power is supplied via a 3-meter extension cable routed from the technical compartment and hidden inside a routed channel, keeping the wall surface clean and flat. The result is a modern, compact entertainment setup seamlessly integrated into the camper without taking up living space. To complete the camper's electrical system, I installed a light switch using a concealed wiring method to keep the interior clean and minimal. I marked the position on the wall and cut a recessed box about 3/4 inch deep to house the switch and accommodate the wiring. Power cables from the fuse panel and outgoing wires to the light were routed through the wall into this cavity. I then carefully connected them to the switch, ensuring correct polarity and safety. Once connected, the switch was securely fastened into the wooden frame behind the wall, keeping the surface flat and flush. I upgraded the ceiling frame using 2-inch wooden beams to route electrical wiring inside the frame without cutting into the 3.8 centimeter insulation layer, while running a main line for 6 12-volt recessed LED lights with wire loops left at each position for easy connection and a clean, organized setup. I assembled the entire ceiling frame directly on the workbench to ensure maximum precision. Cedar wood strips were fixed using construction adhesive combined with nails, forming a solid single-piece panel. I then pre-drilled circular holes for the lights using a hole saw, ensuring perfect alignment before installing it into the vehicle. When installing the lights, I cut the wire loops, stripped the ends, and used Wago connectors for quick, safe, and clean connections. The recessed LED lights were then pushed into the pre-cut holes, where spring clips automatically lock them firmly into place. The result is a cedar ceiling panel with 6 integrated LED lights that is strong, clean-looking, and can be installed as a complete unit to create a warm and premium interior space. I tested the lighting system with temporary power before installation, used temporary wooden supports while securing the ceiling panel, and routed hidden solar cables to the electrical cabinet for a clean setup. I started building the final door wall by constructing the frame, adding insulation, and using custom 3D printed pieces to create precise, rounded door corners. The surface was then filled with expanding foam and reinforced with fiberglass for added strength and durability. Next, I built the doorstop flanges from plywood by cutting them to match the doorframe shape, then securing them with construction adhesive and nails to create a raised perimeter around the doors. All joints and gaps were then sealed with silicone to improve water resistance, provide support for weather seals, and help the doors close more tightly. Once completed, the wall panel was ready for painting and installation onto the camper. The result is a strong, weatherproof wall system that is ready for the final door sealing system. To create a flat and solid surface in this area, I installed additional 2x2 wooden supports to build a strong backing structure. The cedar wall panels were then attached using construction adhesive and brad nails, keeping everything aligned and secure while the glue cured. To bend the 3.8 centimeter thick insulation foam around the curved body of the camper, I used a kerf cutting technique by cutting multiple parallel grooves about halfway through the foam. This made the rigid material flexible enough to bend without cracking. Before installation, I filled the grooves with adhesive to lock the curved shape in place once formed. The foam was then gradually pressed against the vehicle frame and secured section by section using screws and washers. The result is a seamless, strong, and tightly sealed curved insulation layer that closely follows the vehicle structure. To create the complex exterior curves, I used custom 3D printed pieces shaped precisely to match the vehicle frame instead of cutting them by hand. After sanding for better adhesion, the pieces were glued directly onto the frame, creating strong and sealed corners ready for the outer waterproof layers. After completing the framing and insulation, I began sanding the entire exterior to create a smoother and flatter surface. Next, dents and gaps were filled with body filler and refined through multiple layers to create a smooth surface before fiberglass installation. During this process, I also discovered that the solar wiring had been routed incorrectly and fixed it before everything became permanently sealed. After that, layers of fiberglass combined with epoxy were applied across the body, gradually turning the entire structure into a stronger, seamless, and more weather-resistant shell. Once the fiberglass layer was complete, all seams and edges were trimmed and sanded smooth to create a clean surface before painting. Finally, multiple coats of primer and exterior paint were applied, combined with gray and black accents to create a more modern appearance. In just a few days, the rough structure gradually transformed into a complete mini camper with a clean, premium, and distinctive look. I built the main door by cutting plywood to fit the opening, adding a wood frame to match the wall thickness, then shaping the edges, adding insulation, securing everything with glue, and finishing it with fiberglass and paint. Next, I installed the RV lock system, mounted stainless steel hinges, and aligned the door using spacers to create even gaps for smooth and secure operation while driving. To improve waterproofing, all lock areas, drilled holes, and door edges were carefully sealed and fitted with additional weatherproof gaskets to ensure a tight, water-resistant seal. Finally, I cut the pre-marked window openings, applied waterproof butyl tape around the frames, and tightly secured the windows into the vehicle body to ensure a strong sealed and leak-proof fit. I also built a small rear access door for the storage compartment using solid wood, installed a cam lock, and fixed it directly to the drawer system for secure integration. As a result, the camper, originally a sealed box structure, gradually evolved into a fully functional living space, complete with doors, windows, strong weather resistance, and abundant natural light. To install the roof ventilation fan, the top priority was waterproofing. A rubber gasket was placed around the fan edges to seal the gaps between the unit and the uneven roof surface. The fan is secured using roofing screws with integrated rubber washers. When tightened, the washers compress to seal the screw holes and prevent water from leaking in. Once installed, the fan sits flush and firmly on the roof, remaining waterproof even in heavy rain, while the interior cabin stays clean and neatly finished. I used a 150-watt solar panel with a strong aluminum frame, but due to its large size, it is exposed to strong wind forces when driving at high speed. I did not fasten it to the outer shell, but instead anchored it directly into the internal wooden roof structure. Using a frame layout map, I precisely located the structural beams to secure the Z-brackets and applied butyl tape at all mounting points for waterproofing. The wiring was routed from the roof into the internal technical compartment using MC4 connectors converted to XT60 to connect to the EcoFlow power station. The final step is installing a shore power system to connect external electricity to the camper's internal battery using a dual through-wall port for both input charging and output power supply. The unit is installed near the electrical cabinet and sealed with a waterproof gasket and sealant, with the input connected to the EcoFlow charger and the output to the AC outlet system. To prevent movement during driving, Drew installed 4 heavy-duty stainless steel draw latches at the corners to securely lock the camper to the truck. The hooks were fixed to the truck body after exposing the metal surface and drilling pilot holes, then secured with stainless steel self-tapping screws. The matching latch parts were mounted into the camper's wooden frame, with all holes sealed using silicone for waterproofing. The latches were then tightened and adjusted for a firm, stable lock. I improved the bed by building a base from 1/4-inch plywood, then cutting a 6-inch mattress to extract the memory foam and shaping it to the exact size. I upholstered it by laying out the fabric, placing the foam and plywood on top, then pulling it tight and stapling it underneath, folding the corners neatly and sealing them with hot glue like a gift wrap. I also used leftover foam, cut into angled pieces and glued onto a board to create a wedge-shaped backrest for more comfortable seating. I then cut the memory foam to match the angled shape and upholstered it the same way as the bed. This design works as a sofa during the day and can be removed at night to extend the sleeping area. I then installed walnut wood finish peel and stick vinyl flooring by measuring, cutting, and applying it directly onto the plywood. With a small area of about 6 square feet, the process was completed very quickly, leaving the interior clean and cohesive. The mini camper was then ready for its first trip. As the vehicle rolls forward, the workshop chapter comes to an end, giving way to the real journey on open roads. The small camper quietly moves through peaceful countryside, blending into the vast landscape like a dream finally brought into reality. By sunset, the van comes to a stop beside a calm lakeside. The interior lights gently turn on, casting a warm glow into the twilight, turning the camper into a small yet steady, mobile home, standing peacefully within the vastness of nature.